Hello there, I'm Dr. Andy Lovelace. I've taught at the University of Washington for over 20 years, and I want to give a little background for our Math 120 course. I really love the course, but I want to make sure it's the right fit for potential students taking it. So a little bit of background here, small bit of background, then I'll talk about the course, and then I'll do a little more history at the end. So stick with me here. We use our own textbook that was written by Dave Collingwood and Dave Prince in the 90s. They did statistics at the time and saw students coming out. We used to teach a very traditional pre-calculus course at that time. That was before I was here. But we found students coming out of it that got like a 3.0. A lot of them weren't doing very well in our calculus series. So Dave Collingwood, who was a longtime instructor, and Dave Prince, who worked with tutoring students in the engineering program, they thought, the main thing that students are struggling with when they get to the calculus is the problem-solving component, using the math. So they designed this book and then refined it over several years to focus on this idea of building that skill up. And after that, it kind of reached this form in the early 2000s that seemed to work pretty well, and there was data suggesting that, hey, people that came through this were doing better than the previous group. So it's trying to hone a problem-solving and mathematical modeling skill as opposed to just learning a bunch of rote skills from pre-calculus. So that's kind of what this course is about. For me, as the instructor, I'm teaching it this fall, but I'm trying to make this video for anyone interested in this course. It's about getting you ready for the calculus series in a way that is valuable. Everything we do in the course is an application. We don't have to justify why are we doing this. It does mean you don't get as much of the standard practice. Okay, so let me say a little bit more about that here in a second. But first, just a shout out to Dave Collingwood and Dave Prince, and then Matt Conroy, who's a teaching professor in our department, has edited the book for many years. It's all self-contained. The chapters are fairly short. But it starts in a different place. It's about this story problem stuff. So I'm going to grab a few excerpts from there and then say a few things about it. I even get my name in there because I've taught this course so many times. Okay, so a few specific notes. So because the course was designed to be about this problem-solving component, and because it was for college students who've already been through Algebra 1, Algebra 2, and other things, the course assumes several things. So that's an important thing for students to know. So if you're taking this course, we're going to assume that you've seen the equation for a line. We are going to recap it, but we're not going to do a bunch of rote practice on it. So you need to be able to find the slope of a line, know what it means, know how to label things on the line. We're going to talk about quadratics, but we do expect like you've seen the quadratic formula. I think in the second homework set, before we even get to quadratics, you have to use the quadratic formula. So some students are like, well, I don't know that, or I don't remember that. So that is a problem we can tackle, but it's something you need to be aware of, is that we're not teaching those skills. We will recap them, but that's not the main focus. This also includes exponentials and logs and basics of functions. That's the first 12 chapters. The last 8 chapters, we tackle other things like rational functions and trig. And we also assume a little bit is known about trig. So the reason I say that is there are other courses at UW. They're not taught by our math department. They're listed as math, but they're taught by the instructional center. And if you're saying, I don't know how to find the equation of a line, I don't know the quadratic formula, I can't remember how logs work, and you have no memory of them, then it might make more sense to take these courses. There's open spots this quarter. Teresa Ma runs the program. She really wants students to succeed. She wants me to advertise and say, send them here rather than have them take 120 and then have to do this later. These people are your allies, and they will give you the tools you need to be ready for this course. So anyways, those are there. Check with the instructional center if you find that right away you're in trouble. All right. And for my students, if you're taking it from me, you can ask about any of these things, and I will give a quick review. It's just things will pop up that you need to have some, at least sort of memory of those pieces. Okay, So a little bit of this comes from the preface of the book. And I know you can't read those. These are in the text. The text is freely available online. You can, find it and read through it. But their idea was to make every problem a story problem. Now students say, I hate story problems. Yeah, because it requires reading and translating from the words to a picture to equations. But that really is the skill you need in calculus, to be able to go from the equations to the graph or the picture. And so we focus in on that skill. It does require you guys going to be a little bit of reading, but we're going to give you a lot of strategies. I find that people get more out of this course than any other course I teach. So if your goal is really to understand and move forward, there's a lot to learn here. In terms of errors, this is what they wrote in the 90s, that the errors we see in calculus are algebra errors, which is true. Some would argue we should spend more time on algebra in this class. It's an argument that actively goes on in our department. But students have seen algebra lots of times, and I don't know a bunch more practice in this class if that's more important or not. But you will do algebra. It'll just be part of doing problems. You'll be doing algebra in the same way you'll be doing algebra in our calculus courses. That's kind of the thinking. So algebra is an issue. Visualizing and putting things in a picture, that's an issue. It's still an issue. And knowing your definitions from your previous courses. I would add to this now that arithmetic has become a bigger issue because, post-pandemic, plus now there's the AI trend. People are more used to having something else do their arithmetic, and that is another major source of error that makes it hard for people to even get to the problem because they make a lot of arithmetic errors. All of those things you'll get a lot of practice of in this course. So I do think that a lot of the most common errors that we see on our calculus finals, if you take this course seriously, it will give you practice with these things. But ultimately, we're learning this new language. This is the language of the sciences. So this is a valuable place to open doors to lots of things for you. So I hope that's interesting to you. It will be different when you dive into the homework here. I did want to show one thing before we leave here. So here is an example of what an exam would look like in this course. So it requires students to think of things a little more like an essay question. This is from an old final. So this is my solution. But the question was like, there's a plane flying from one city to the other. How long is it in the radar region? Once you get in the habit of doing a problem like this, it's not quite so bad because you're going to say, well, I need to find the equation of a line. And you have 2 points and you find the equation. But it isn't like other courses where you just plug into a formula. So it gets you to approach problems in terms of you sort of writing down what you know. So anyways, you have to find the equation of the line, you have to find the equation of the circle, you have to intersect. Doing the intersection requires some arithmetic. We give a lot of partial credit along the way. But you can see in doing multi-step problems like this, you're going to build up this stamina you need so you can be more successful in calculus. But it's a different approach. Sometimes that's dramatically different from what students have seen in other math courses. And if that's true, that means this is really valuable for students to see this. Some other examples from this test. So we talk about modeling. So yes, we're talking about exponential functions, but can you use those to actually plug in numbers? Here we have just straight solving, functional notation. That is an important skill. Here we have quadratics. How do I find the vertex? How do I solve with a quadratic? And then we get into trig and circular motion. So you can see this multi-step idea. That's what we're trying to get across here. It does mean as you do the homework, you have to embrace that. You have to treat each homework question as, okay, here's where I got, here's where I'm stuck, and then come use all your resources to get help. So it's not like you're going to sit down and just do all your homework because it's plug and chug. It's not going to be like that. But if you embrace it, I think you'll get a lot out of it. All right, I hope that gives you a little more background of what this course is about.